Hello students, today we wanted to do a little recap on how you find the area of a parallelogram and the area of a triangle. So we're going to use a GeoBoard to help us with this. When we're finding the area of a rectangle, we can always take the length of each side. In this case, we need to count the spaces between the pins on the GeoBoard. 1, 2, 3, 4, 5. We can take the length and we can take the height. 1, 2, 3, 4. So 5 times 4 is 20. So we have 20 square units. A square unit is the area inside 4 of these pegs. So when we're talking about area, we're talking about how much space something covers. So we're talking, we want to know how many of these squares there are altogether. If we take our GeoBoard and modify it slightly, so for example, let's make a parallelogram, and we're going to do that just by moving this pin over 1, 2, 3, and we're going to move this pin over 1, 2, 3, and we want to see if there is a link between the size of the shape we had before, the rectangle with 20 square centimeters, and this new shape. Well, imagine we take our GeoBoard and we look at this triangle here I'm outlining. What if we were to take this triangle and actually move it over to here? In other words, we take the triangle and this point here, we make this point move over. And because this point is over there, we're going to go over 1, 2, 3. We're going to move over another 3. 1, 2, 3. So this now becomes the base of this triangle, and we're going to extend it up to the top. So in other words, what we're doing is simply cutting off this triangle and moving this triangle over to this space. And we can see what we've outlined now, and I'm going to outline it in green for you, is a new rectangle, which is the same as our previous rectangle because we've moved these squares over. So let's just take this off so we can get rid of some of the confusion. And what we'll see is we've simply moved those triangles over in order to create a rectangle with the exact same area as we had before. In other words, 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. So the area of any parallelogram can be found by simply taking the base, which is the area at the bottom, times the height, which is the distance straight up and down. So for this smaller one I've just made, the area is going to be 1, 2 times 1, 2 tall. So the area is base times height. Now, if we reset our GeoBoard and we look at a triangle similarly, we can take our we can create any triangle we wish. So let's make this triangle. And if we have our triangle, we can create a square around our triangle. This is what we did in class. So we simply take our elastics on our GeoBoard. Hopefully you remember doing this. And we put them around our triangle so they completely enclose our triangle. The area of this rectangle is 1, 2, 3, 4, 5 times 1, 2, 3. 5 times 3 is 15. Our question is, what is the area of the triangle inside? If we imagine taking our triangle, our rectangle, and cutting it in half, so I'm going to put another elastic in there to make it easier to see. You can see now that there's actually 2 rectangles here. So our first rectangle is 1, 2 times 1, 2, 3. So this has an area of 2 times 3 is 6. But the portion of the triangle that is still inside of this rectangle is exactly half of the larger rectangle. So since the area of this rectangle from here to here to here to here is 6, the area of this space in here must be 3. Likewise, the area of this part of the rectangle is half of this larger rectangle, so it's 1, 2, 3 times 1, 2, 3, which is 9, 9 divided in half is 4.5. So we have an area here of 4.5. We have an area here of 3. So 4.5 and 3.5 is 7.5. However, if we count 1, 2, 3, 4, 5 by 1, 2, 3, 5 times 3 is 15. So 15, and then we see that this rectangle or this triangle is half of the area of the larger rectangle. So we have 15 divided by 2 is 7.5. So the area of any triangle is the area of the base times the height, which is the distance straight up and down because we want to cut it in half. Base times the height, and then we're going to divide it by 2 because we can put a rectangle around it. So the area of a triangle is base times height divided by 2. So we've got two formulas now. The area of a parallelogram is base times height, which is the same as the area of a rectangle, and the area of a triangle is base times height divided by 2. I hope that you found this helpful. I'll put the link to this site online so you can go to it anytime you want. Thank you.